This video will cover some of the basic characteristics of Asteroid Bennu, a near-Earth asteroid that material will be gathered from, hopefully, October 20th. So let's cover some of the orbit and basic characteristics of this asteroid. It was discovered in 1999. It's a small object, so it's not been known for a long time. And it's a characteristic of its orbit. I'd remind you, the Earth's orbit, the average distance is what we call 1 AU, 1 astronomical unit. For Bennu, the perihelion, when it's closest to the Sun, is 0.897 AU, so it does get closer than the Earth to the Sun by a little bit. Its aphelion, when it's farthest from the Sun, is 1.356 AU, and it takes 1.2 years to orbit the Sun. You'll notice that it goes inside the Earth's orbit, goes outside the Earth's orbit. So in terms of distance, it crosses the Earth's orbit. However, the orbit of the asteroid is inclined relative to the Earth's orbit by about 5 degrees. And we'll take a look at some of the diagrams that show these orbit characteristics. So Bennu is in this aqua type color. So it does go inside the red orbit of the Earth. We've got Mercury, Venus, Earth, and Mars. I couldn't find an English labeled slide that looks like this. So it does go inside in terms of distance. But if we take more of three-dimensional view, and this bottom illustration, the asteroid does have a tilt to its orbit compared to the Earth's orbit. So at the time when it's the same distance away from the Sun as the Earth, it may be above the Earth's orbit or below the Earth's orbit. There's not a definite possibility of a collision. Not a definite chance of a collision because sometimes the asteroid is above our orbit and sometimes below. And also, when Bennu is at the same distance away from the Sun as the Earth may be quite a ways in angle different in its orbit from the location of Bennu. Astronomers have done some computer simulations of the future, and I think I read there's one chance out of 2,700 that Bennu may have a close encounter with the Earth in the late 2100s. So nothing immediate here to concern yourself about unless you're watching this video in the year 2180. Probably not. So let's talk about some of the characteristics. It is a small asteroid, 510 meters. We have it taller than the Empire State Building, but not as big as the Moon, not as big as the Earth. About 1670 feet across the asteroid. So not a huge object. Density is determined to be 1,190 kilograms per cubic meter. We should compare that to water. Water is 1,000 kilograms per cubic meter. So we can see that this is not solid rock. The asteroid is not solid rock. And there are indications that it's sort of a rubble pile of collected rocks with air gaps, not in space, but gaps between the rocks. Some people have called it a rubble pile. And perhaps 20 to 40% of the inside of the asteroid is empty. The rocks are not compacted together. There's not enough self-gravity of the asteroid material to pull the rocks, crunch them closer together. Its surface is very dark. For the sunlight that comes in, only 4% gets reflected back out into space. To compare that with the Earth reflects about 30% of the incoming sunlight. Does not get absorbed by the Earth. And there's extra carbon on this asteroid compared to the normal asteroid. So it's a carbonaceous asteroid. This carbon is not related necessarily to biological activity. It doesn't mean there are plants and coal and such on the asteroid. It just means there's a little extra carbon compared to other asteroids. It is a spinning object, one rotation every 4.3 hours, so faster rotation than the Earth's 24 hours. A very interesting video of the surface of Bennu in a rotating view of photographs that have been collected at this website, nasa.gov/feature/Goddard/2020/Bennu-top-10. There's extra information on there, but one part of that webpage has a nice video. Here is one frame out of that video, and you can see that there are rocks, there are boulders across the surface, and this website gave some facts about those boulders. 200 boulders larger than 10 meters, so that's larger than 30 feet. And the largest boulder goes 58 meters. So again, roughly multiplied by 380 feet or something. But it is a more rocky surface, boulders, than what was expected before the spacecraft OSIRIS-REx was launched to the asteroid. A little closer detail of some of the locations, and these are target landing, or not landing, I shouldn't say landing, but target sample location sites that have been identified. Bennu is, I think, an Egyptian term related to birds, so they've named these targets with different types of birds. This is the prime target, Nightingale, for October 20th, and it's a little over 60 feet across here. So this is taken from a kilometer away, 1,000 meters away, by the spacecraft OSIRIS-REx. They are picking this site because they think it has a good amount of fine, dusty, sandy material that will make it easier to collect a sample. So if you're watching this before Tuesday, October 20th, 4 o'clock Central Daylight Time, there'll be coverage, and 5:12 p.m. Central Daylight Time is the touchdown time, but I think it's about an 18-minute radio delay from Earth to the asteroid. So we won't get information right at 5:12 that the touchdown and sample collection was successful. That'll take a little while, but there will be some reports Wednesday, October 21st at 4 p.m. So here's more information about the mission to Bennu, and information about the asteroid, and nasa.gov/NASA Live, I think, would be a good place to tune in on Tuesday and Wednesday. Just for future reference, NASA does have a public TV channel. This is not the one that will be used for the announcements. So this is just about the asteroid Bennu, primarily, for this video. I'm going to record another video related to the spacecraft and the OSIRIS-REx mission. So if you'd subscribe to my YouTube channel, there's no cost to do that. I don't ask for any donations. And look in my playlist. The playlist is titled Astronomy Images and General Interest. And in there, look for the OSIRIS-REx video. If you want to view some other physics and astronomy videos, my websites have listings of what videos are available with their title, how many minutes long they are, a little description of the content. And again, these are totally free, no registration. I do not collect email or names or anything. And the websites are pretty rudimentary. They're not fancy at all, but hope it can provide you some information.